Hi guys, and welcome to the video on area and perimeter for kites and trapezoids. Alright guys, in this video we're going to learn how to calculate the area and perimeter for kites and trapezoids. Because kites and trapezoids are used in garden-shaped designs, and a lot of times these are things we can do with building and design, so engineering. You'll know you're successful when you can find the area of a perimeter or kite or trapezoid if you are given the parts. So let's just get right to it. Alright, the area of a kite is given by the formula diagonal P, the short one, times diagonal Q, the longer one, divided by 2. And for the perimeter of a kite, you just need to add all of the sides up. Because the adjacent sides of a kite are congruent, all you have to do is multiply 2 times the short side and 2 times the long side and add them together, and you have the perimeter of your kite. One of the things that's going to be super useful to us here is that if we know what the diagonals, we can go ahead and remember that they intersect at a 90-degree angle. So if we know the diagonals, we're allowed to use the Pythagorean theorem to find missing side lengths. So let's not forget the Pythagorean theorem here. To calculate the area of a trapezoid, you're going to go ahead and add the two bases together. So it's kind of like the formula for kites and for rhombuses, but you're going to add the bases together here and then divide by 2. And then again, remember that the height, and then you have to multiply that calculation by height. So basically what you're doing is you're taking the average of the two bases, and then you're multiplying that by the height. And again, the height is actually the altitude. The height needs to make a 90-degree angle, so no 90, no good. No 90, no good. Alright, and then the perimeter of a trapezoid is found by summing all of the bases sides together. Because in a trapezoid, bases are not the same length, and legs are not always the same length, we have absolutely no guarantee that we can just multiply them by 2. If it's an isosceles trapezoid, yeah, that makes our life a lot easier, and then we can multiply by 2. But in the case of where that's not true, like we don't know that it's a isosceles trapezoid, we just have to resort to multiplying everything by, or adding everything together individually. So let's just get right into some examples then. What is the area and perimeter of the kite below? So it's really easy for me to calculate the area of this. Remember that the area of a kite would be P times Q divided by 2. P in this case is going to be 4 plus, or excuse me, P is the short diagonal, so that's going to be 3 plus 3. And then that is going to be 6 meters. And then the Q is going to be 4 plus 9, which is going to be 13 meters. Oh, my M looks really bad there. I'm going to just fix it. 13 meters. So I need this and this measurement for my area formula. So area is going to be equal to 6 times 13 divided by 2. So the area here is going to be equal to 6 times 13 is going to be 78 divided by 2. And so the area is going to be 39 meters squared. The perimeter is a different story in this case. I don't have any of the sides of my triangle, so what I need to do, or of my kite, so I need to label this one Y, and this one would be Y over here as well, since these are congruent. And then this one over here, and this one over here I know are congruent since it is a kite, and we're going to label them X. So to find either one of those, what I need to do is do the Pythagorean theorem. And so I am going to go ahead and, oh man, I made it even worse. I'm going to go ahead and just go ahead and do 3 squared plus 4 squared equals x squared. Because x, all of these, so for all of these, the sides are going to be the hypotenuses. So I get 9 plus 16 equals x squared. And you guys have kind of seen the result of a 3 and a 4 a couple of times now in a few of my videos. 25 equals x squared. So you take the square root of both sides. X is going to be equal to 5 meters. So I can put a 5 here and a 5 up here. But what I need to do now is do the Pythagorean theorem to find y. So it's going to be 3 squared plus 9 squared equals y squared. So 3 squared is 9. 9 squared is 81. That's y squared. So I get 90 equals y squared. So I take the square root of both sides, and I get y is equal to, so 90 is not a nice perfect square, but what is good about it is that I can just, in this unit, rounding to the nearest tenth like this, 9.5, is completely precise enough for our purposes. So we have 9.5 and 5 meters, so y is 9.5. And that makes this 9y, this y 9.5 as well. So to do the perimeter formula, capital P rather than lowercase p. So actually, I'm gonna rewrite it to make it look a little more like capital. We're gonna do 2 times side 1 plus 2 times side 2. So the perimeter here is going to be 2 times 5 plus 2 times 9.5. So the perimeter, with capital P, is going to be equal to 10 plus 19. So the perimeter is going to be equal to 29 meters. 29 meters. Okay, so that was area perimeter of a kite. Here, again, another area perimeter of a kite. I'm going to have to flex and use some extra properties of kites from Unit 6. The first property of kites that we know of is that this small segment here is equal to this small segment here. So I can put a 5 right down here. And so area is equal to P, small p, times Q, not P for perimeter, but P for diagonal P, over 2. Little p here is going to be equal to 5 plus 5. And Q is going to be equal to 6 plus 12. So I've got 10 for P, for little p, the diagonal, and 18 for Q, the longer diagonal. So I can go ahead and substitute those in. I've got 10 times 18 divided by 2. So on the top, I'm going to get 180, and on the bottom, I'm going to get 2 still. So the area is equal to 90, and they didn't give us a unit, so it's just units squared. Now, for the side lengths here, I'm going to have to use the Pythagorean theorem to calculate these side lengths again. And then I see they already have marked as congruent. So all I need to do is find one and then use the perimeter formula. So capital P is equal to 2 times whatever side 1 is, plus 2 times whatever side 2 is. So let's do Pythagorean theorem here. So to calculate this one here, it's going to be 5 squared plus 12 squared equals, we'll call it x squared. We've seen 5 and 12 before. 5 squared is 25. 12 squared is 144 equals x squared. So I get 169 equals x squared. So the square root of that is that x equals 13. So I can put a 13 into my perimeter formula. So 2 times 13 plus 2 times, I still have to find the second side. So for this one, it's going to be the 5 squared plus 6 squared equals, we'll call it y squared. So 5 squared is 25, 6 squared is 36, equals y squared. So 61 is equal to y squared. So then you go in, and we know the routine here at this point, guys. We've done Pythagorean theorem so many times. We take the square root of both sides. y is going to be equal to 7.8. So this up here and that there will be 7.8. So I'll put a 7.8 into my parentheses here. And then I can go ahead and multiply and add. I get 26 plus 15.6 for the second one. So the perimeter of my shape, capital P, is going to be equal to 41.6 units. And there we go, area perimeter of a kite. So let's tackle area perimeter for a trapezoid. So the formula for area of a trapezoid is that you have to average the bases. So B1 plus B2 divided by 2. And then you take that calculation and you multiply it by the height. And then the perimeter is going to be adding all the sides together. So side 1 plus side 2 plus side 3 plus side 4. So the perimeter one I'm just going to go ahead and do right away because it's a quick calculation of 4 plus 5 plus the other one is 5 plus 8. So the perimeter here is going to be equal to 4 plus 5 is 9, plus 5 is 14, plus 8 is 22 meters, since that's the given measurement. And for the other measurement of base 1 plus base 2, we're going to go ahead and start filling that in. The first one is 8. Second one is 5 divided by 2. So that's the first calculation that I'm going to make, times the height of 4, because the height needs to make 90-degree angles with both bases, and 4 is the side that makes 90-degree angles with both bases. So then I'm going to go ahead and do my calculations here. 8 plus 5 is 13. 13 divided by 2 is 6.5. So 6.5 times 4. So then the area is going to be 6.5 times 4, which is 24 plus another 2, or 26 meters squared. All right, and then finally, what is the area and perimeter of the trapezoid? Okay, so we're going to have to do a little bit of preliminary work here in order to be able to actually calculate any of these. Okay, they state that there are 45-degree angles in this trapezoid. So what I'm going to do is draw a second height in. I know that the distance from here to here has to match what's on top because this is a rectangle. So this is a height of 6. That's 12. So this distance has to be 12 here. But what I am missing is this distance here, and I am missing this distance here. In order to actually calculate it, what I am going to need to recognize is that I have a 45-degree angle, a 90-degree angle, making this a 45-degree angle up here. And then up here, this would be a 45-degree angle as well. So these are 45, 45, 90 triangles. So then I can go ahead and multiply, or I know that this 6 and this 6, or this here has to be the same. So this missing measurement has to be 6. And this missing measurement also has to be 6. So the entire base, when added together, is 6 plus 12 plus another 6, or 24 units on the bottom. To actually calculate the lengths of these legs here, I am going to need to do the Pythagorean theorem. So I'll just put x and y. So this is all of the grunt work I have to do for this trapezoid before I actually calculate its area and perimeter because it's missing so much information. That's what I have to do. It's what I recognize that I have to do here. So I'm going to do for the x squared equals 6 squared plus 6 squared. So x squared equals 36 plus 36. So you get x squared equals 72. You take the square root of both sides, and the square root of 72 is a decimal, and that decimal is about, so x squared is about 8.5. Not x squared, oops, not x squared anymore. X is equal to 8.5. And then because I can see these measurements are the same on the other side, I can repeat the process. So repeat for y. Repeat for y, and that means that y is going to be equal to 8.5 as well. So now I have all the measurements that I need to do this all of my calculations. So the area is going to be equal to, base 1 is 12. Base 2 is all three of those segments, 6, 12, and 6 combined, are 24, divided by 2, and they're multiplied by the height of 6. So the area is going to be equal to 12 plus 24 is 36. I took my bracket a little too far. Divided by 2 times 6. So the area is equal to 18 times 6. And so that area is going to be equal to 108. And they didn't give us units, so we'll say units squared. And to calculate the perimeter here, the perimeter is just going to be all the sides added together. So I have an 8.5 side, I have a 12 side, I have another 8.5 side, and then I have the bottom base of 24. So the perimeter is going to be equal to 8.5 plus 12 is 20.5, plus another 8.5 is going to be 29. 29 plus 24 is going to give me a total of 53. So 53 units. And that's it, guys. So the formula, in summary, the formula for area of a kite and a trapezoid, they're pretty similar, but they're slightly different, okay? Remember that kites, you're multiplying the diagonals, whereas for the trapezoid, you're adding the bases, so don't get them mixed up. That's the biggest mistake that I see is when people do trapezoids, they start to multiply the bases. You need to add the bases for multiplying, or for a trapezoid. Please make sure that you remember that you have to still add up all the sides to calculate the perimeter for any shape. These ones, you're going to have to add 4 different ones, but kites are nice and simple because they have 2 duplicates. And then make sure you remember that you can find the measure of any slanted sides that are missing using the Pythagorean theorem, like in example 4, and we did it in example 2. So that's it for today's video, guys. Thanks for watching, and I'll see you in the next one. Bye-bye.